Okay. Anything you guys want to talk about from the text? Or just kind of want to review some more stuff from the chapter. You can't hear me.
Wondering how specific things are going to get on like scientific notation and the UGs and the I don't do numbers great.
There's not a lot of math in this class per se. It shows a lot more in the text than there is in the actual class. Let's see if I can find something to show you. Let's go over here, go here.
And when we were going to start kind of getting into like the mathematical aspects of it, I guess, and like how much like chemical equations that we're going to be doing.
See, I don't consider that math. So you guys can see this course content guide? Is that a yes? No? Maybe? Yeah, okay. So we're definitely going to get into some a little bit of dimensional analysis, metric system-y kind of stuff in scientific notation. So yeah, I mean there's a little bit of math here, but not a ton, not as much as you might have thought. But like the prefixes, like you said, UG, so that's micrograms. So yeah, like those prefixes, I'm sure you know. Let me find the page that it's on. Like kilo. I mean, you obviously have heard that before, and so that's just means 1,000. And so the in chapter 2.
I just figured out how to run Moodle.
Excellent.
There's some like intravenous medications that like on the bottle has UG on there instead of like milligram. I thought that was kind of interesting. I didn't correlate that.
UG isn't milliliter.
I've seen it before though.
Yeah, but U is micro.
So microgram, MCG.
Yeah, see, that's a healthcare thing. U, or mu, what it actually is micro. MCG is hospital lingo for micro. A lowercase m is milli. So lowercase mg is milligram, not microgram. Looking at metric system units. What page is that on? You'd think it'd be in the index. You would be wrong. Probably under scientific or
But the class is mostly kind of contextual and how, like the title, like the book implies.
Right. So definitely contextual, but inside of that context. So what that really means is instead of just talking straight up about micrograms and stuff, talk about where micrograms would be used. So if we're talking about micrograms and milligrams, or so in the first chapter we were talking about, last class we were talking about pollutants, and I had a discussion about how bad the weather can be in the Dalles because of just the arrangement of the river and the mountain ranges on both sides. And in the winter we get mostly easterly winds, so you get all of that particulate that comes from like the Boardman coal plant. So one of the things that people measure are the size of particles within smoke, and that's a PM 2.5 and a PM 10.
Page 23, yeah.
Sorry, 23?
Mm-hmm.
Okay, so then they are using.
But that's it. Yeah.
They're using that
physical measurement.
Right. So they're, instead of us just straight up talking about pico, And then what pico means, this is telling you exactly what that is used for. So the contextual portion of it is, why are we talking about picometers? We're talking about picometers because when we're measuring air particulate and its ability to affect a person, we use picometers, the 2.5 and the 10. So that's what we mean by the context part of it. There we go. Sorry, it was a little warm. I had to cool off. All right, so I work best with somebody saying, hey, so I saw this question and I don't understand it. So does anybody have a question maybe that they saw in the text, or maybe at the back of the texts in the extra questions, or maybe one that somebody posted on the forums? Or just something you were looking at and was confusing? So last time we were talking about, dang it, sure. Last time we were talking about balancing equations. I feel like the people who were here mostly had it at the end, but I was kind of thinking that we could start with talking about a little refresher on that. Do you feel better about that now, Sam? Yeah.
And I know I'm kind of like a visual learner, so when I see a picture like this, like a
Right.
visual representation, I'm like,
Sure.
oh, I get it. Okay, so I think I might just have to draw bubbles,
Sure,
and
that's
then
the space filling model.
yeah, and then I also got this too a while back. 'Cause I knew I was going to be taking chemistry. I don't know if you've seen it before. It's like
Oh yeah.
the Cliff Notes version, and it has like different
It's got a lot of problems
examples.
worked out for you.
Yeah, like, and you can do it yourself, that sort of thing. So I'm going to try and utilize this as much as I can to help me figure these out.
Okay. So maybe we don't want to do any balancing or anything like that? No.
I mean, I wouldn't mind doing some again.
Okay.
I take some balancing.
All right.
A
Let's.
question.
Yeah. Go ahead.
So this is the first time I've actually taken any
Online class.
formal online classes.
Okay.
So I'm halfway through the first chapter. Can I still turn in my notes to you, or is that?
Oh yeah. No.
just move on?
Here, let me back out of this for a sec. So here are the list of all the different reading notes we're going to do for these first 8 chapters, and a couple of things you can do. One, you can just click on it, and then it tells you right here that this is going to be due Thursday, January 23rd.
Okay.
So then down here just below, it'll show you that here's the second reading guide. So you can just click on over to the second one. That's also due on January 23rd. Do any of you guys remember why January 23rd was the day that I had those for you to be completed?
Before the quiz.
Before
something?
the first exam is on the 24th. So I figure you should probably be finished with the reading notes for exam for chapters 1 and 2, since that's going to be exam 1. So that's how it works. Every 2 chapters is an exam, and those chapter notes are due the day before the exam, just so you get it done and do hopefully what it's supposed to do, which is learn something out of the chapter and then show me that you learned it. So yeah, you can absolutely turn those things in. And even if you turn them in late after the 23rd, you're still going to get some credit for it. It just won't help you as much on the exam. And you don't have to wait until the 23rd to turn it in. You don't have to wait till the 24th to take the exam. If you wanted to finish everything this week you could technically do it. There's nothing stopping anybody from doing that. It's just I set dates to make sure that we're not they're not doing that the last week of class instead of the first week of class.
Are the exams going to be like written or like a combination of written and multiple choice or
They're mostly
blank or?
they're mostly multiple choice, a couple of true and false. I can't. There's no like essay kind of questions.
Oh, thank the Lord. Okay.
Okay. Let's do so topics, worksheets. Okay, can you guys see this big old list of things to be balanced? Yeah? All of a sudden, I can't hear you. Like, what just happened? Nothing like this happened last year. Yeah, can you hear me? You're just mouthing the words. That's all I. This is very strange. All right. Well, I guess it really. No, that's gonna matter because I'm gonna want to hear you guys talk. So, what am I gonna do here? Super frustrating. How about now? No, one of you say something. I know you can hear me. Yeah, no, I cannot hear you. What is going on? Select speakers. Huh. All right, let me turn. How about now? I have no idea what that was. Obviously, something weird is going on. So, when you guys want to ask a question, there's a little chat thing over there. And I can see Samantha saying we can just type questions. So just type questions for them. Okay. So let's go back over to this balancing thing. And, well, I need to share that thing again. Okay, how about, let's start with a pretty easy one. Let me make this a little bigger. It's like all of a sudden, like every key I've got is not working. All right, this number 14. So that's hydrogen peroxide, and then we're making water and we're making oxygen. So you've all, I'm assuming, all seen this reaction happen. If if you get hydrogen peroxide on anything bloody, a wound or whatnot, it fizzes up like crazy. Everybody good with that? So the fizzing are the bubbles that are produced, and the bubbles are pure oxygen. So the hydrogen peroxide breaks down, and you have a whole bunch of water in there, and now you have pure oxygen inside of there. So this is not balanced. And when I look at this, I see 2 hydrogens on the left and 2 hydrogens on the right, so that looks good. And then I see 2 oxygens on the left because it's H2O2, and on the right side I see 1 oxygen in the water molecule and then 2 oxygens in the oxygen. So I'm not balanced. I've got 2 on the left and 3 on the right. We okay with that? Okay, so I don't have enough oxygens, so that's going to be a problem. So what I can do is, let me put a 2 right here. So that just doubled my number of hydrogen and oxygens on the left-hand side. So now what I have are 2 separate hydrogen peroxide molecules. So since each hydrogen peroxide has 2 H's in it, now I have 4 total H's and 4 total oxygens. So on my right-hand side, I don't have enough H's now. So if I put a 2 in front of my water molecule, now I have 2 separate water molecules over there. And since each water molecule has 2 H's in it, now I've got 4 H's on my right side, my product side. So now I've just balanced out my hydrogens, rebalanced them out because they were before. So now I also happen to fix my oxygens, and I'm actually finished balancing this. So if I look on my left-hand side, I've got 4 H's and 4 O's, and on my right-hand side, I've got 4 H's and 4 O's. So there's 2 oxygens right here, and then that shows 1 oxygen, but there are 2 water molecules total, so that means there are my 4 oxygens. Does that make sense? Maybe, what if I stop this and I go back over, oops, go here, and I share this one. All right, so I'll pick, so we'll go, all right, so starting off, this is not balanced because I've only got 2 oxygens here, and over here I've got 3 oxygens. So no bueno, gotta change that. So the way I can do that is I'm gonna put a 2 right here. So this 2 in front of this hydrogen peroxide means H2O2, H2O2. So this and all of this, that's the same thing. So when I look at that, I see I've got 2 H's here, and then I've got another 2 H's here, and I've got 2 O's there, and I've got another 2 O's there. So I've got 4 H's, and I've got 4 oxygens on this side. So to balance this out, I'm going to put a 2 right here. And what this 2 means is 2 separate water molecules. And I still have my oxygen. So now if I look at this, I've got 2 hydrogens and another 2 hydrogens, so that gives me 4 hydrogens. And then let me switch colors here. And then I've got 1 oxygen right there, 1 oxygen right there, and 2 more oxygens right there. So now that's 4 oxygens. So now my 4 oxygens is balanced and my 4 hydrogens are balanced. So this is a balanced chemical equation. We good with that? How about if I do it like this? So that's how they get connected up to each other. So the first one is H2O2, so that's hydrogen peroxide. The next one's a water molecule, and the last one is oxygen. It doesn't really matter why the oxygen has a double bond, it just does. So that's not going to affect anything. So when I want to go balance this thing, I'm going to put a 2 here and a 2 here. So, all right, so what does that mean for us? So that means I've got Okay, so how many H's do I have on the right side? We can't really see that. So there's one there, there's one there, there's one there, and there's one there. So that's 4 on the left. And on the right side, there's one there, there's one there, there's one there, there's one there. So that's 4 on the, sorry, 4 on the left and now 4 on the right. So the H's are balanced. So what about my O's? There's one there, one there. All right, that's really weird. I don't like that. So there's one there, and there's one there, and there's one there, and there's one there. So that's 4 oxygens. On the product side, I've got one there, and one there, and one there, and one there. So it's balanced. So I can't draw the bubble things because I can't draw, but that's the best I can do for you. So you could break it down and write it out like this to show exactly how many H's are on each side and O's are on each side and whatever it is. It doesn't really matter because once you've figured it out, it can't be wrong. Like you can go through here and count just like we did how many H's are here and how many H's are on that side, and you're finished balancing those. And the same thing with the oxygens. So once you've counted everything out on each side of the arrow and they're equal to each other, you're finished. So do you see why we put this 2 here and this 2 here? Is that super obvious? Because I don't want to draw it like this every time and draw it like this every time. So just like in like pre-algebra or something like that, you're supposed to combine like terms. We're combining like terms. All right, so let me find another one. How about I'm gonna put all that there. Whatever. It's not gonna let me make it any bigger. Don't delete it. Okay, so I'll put some spaces in here. All right, are we okay with this one not being balanced because of the sulfurs right off the bat and because of the irons? So in this equation here, I've got an iron, one iron as a reactant, and on the product, I've got 2 irons. So that's not balanced. I also have 2 sulfurs on the left, and I've only got 1 on the right. So that's not balanced. On the left, I've got 2 oxygens, and on the right, I've got 5 oxygens. So those are definitely not balanced either. So then we got to figure this out. So a little tip is do oxygen last. Because it's in more than one of the products, if you change the reactant to balance it out, and then you have to change one of the 2 products, and you get stuck in this weird catch-22 where you change this and change that, which makes you change the first thing you change, and then you sort of get stuck. So do oxygens last. So when I'm looking at this, the first thing that I see is, okay, my irons aren't balanced. So let's just do that first. So I'm going to put a 2 right here. So now that's telling me I've got 2 FeS2s. So my irons are now balanced. There are 2 of them on the left and 2 of them on the right. So I still don't have my sulfurs balanced or my oxygen. So how many sulfurs do I have on the left-hand side? 4. Right? 4 of them because there's 2 FeS2s. All right, so on the right side, we just got 1. Just 1 of them. So I'm going to go ahead and I'm going to put a 4 right there. That just balanced out my sulfurs. You okay with that? Each one of those sulfur dioxides has 1 sulfur in it, so that gives me 4 total sulfurs. All right, so we do have a bit of a problem. The problem in this case is on the left-hand side, my oxygens are even, and on my right-hand side, my oxygens are an odd number. You see that? So it doesn't matter. So how many oxygens do I have on this side over here? There's 3 here, and there's 8 here. So that gives me 11 oxygens. That's a problem because I can't do anything. I'm not going to write 5.5 over here. So the best way to deal with this is everything that I've done so far is okay, is good to go. So I can keep it good to go if I erase this 4 and erase this 2 and turn the 2 into a 4 and the 4 into an 8. So how many irons do I have on the left-hand side? 4. On the right-hand side, if I put a 2 here, now I have 4 here. This is 8 sulfurs. This is 8 sulfurs. And this is 8 sulfurs. So I'm still balanced out. So what this did for me is, how many oxygens are here now? Because it's 3, but there are 2 of these molecules. So 2 times 3 gives us 6. So how many oxygens do I have here? 2 times 8. So that gets me to 16. So now I've got 24 total oxygens. And that's a number I can deal with because I can put, what can I put right here? A 12? Does that work? Because I had 24, right? No, I'm sorry, that's 22. Can't add, evidently. $22. That's better. So this makes sense. So this is 4 of these there's 4 of these molecules. So that gives us 4 irons. And there are 2 of these molecules. So that gives us 4 irons. So my irons are balanced. I've got 4 of these molecules, which gives me a total of 8 sulfurs. And over here, I've got 8 sulfurs. So I know my irons and my sulfurs are balanced. So let's do some cleaning up here. Okay, so we're just checking everything looks good. How many oxygens are here? 22. How many are over here? Well, this is 6, and this is 16. So that gives us 22. So we're balanced. We're good. That's kind of as complicated as they get because we have to bounce back and forth a few times. And I definitely can't do the bubbles with that one. I have to throw 8 sulfur dioxides and 4 iron 4 sulfides. Yeah. All right. This is super frustrating. I can't hear you guys. All right, I'm going to stop sharing this. And it happened all at once, which is the weird part. All participants are muted. All right, how about now? Somebody say something. Nope. Damn. Sigh. Okay. How about I can see you guys are talking. I just don't know what you're saying. Oh, you're just telling somebody else that I can't hear any of you. You know what? I'm going to end this meeting and then I'm going to start it again. Maybe that'll fix it because this is just too much for me.